Good morning, all the students. How are you? I hope you are fine and yes, we wait for 2 minutes for your friends. Already 2 minutes completed, but more 2 minutes we have give time for your friends. Before going to that, please give your attendance all. Yeah, students, already we have discussed our total concept of our laws of motion third lesson. Already yesterday concluded. Once we recall all the things, then after we'll go with the numerical problems, whatever the numerical problems are there. Okay, then after we'll go with the question answer discussion. Okay, yes. Once we go with our yeah, in this lesson, what we have discussed already, in the laws of motion lesson, what we have discussed in already, yes, about the first thing, about a motion and as well as the rest. Yes, why the bodies are under the motion, what is the reason for the motion, why the bodies are in under rest, why the bodies are in a rest, these are the things we have discussed already. Clear or not all the students? All the things we already discussed about that once we recalled about our scientist explanation. Yes, yeah, there is not left, there is no examples, just once after recall of our total concept, once we go with the remaining numerical problems from what IIT components also. Okay now, yes, why? Because this lesson is a very important for your future. Why? Because the laws of motions are only fundamental for the total mechanics. Okay, clear or not all the students? Total mechanics. The mechanics have the main role played in your IIT examinations purpose also, in our physics especially. Yes, remaining all the whatever the topics are there, they are not giving that much of whatever the analyzing nature is not there in that. Why? Because the mechanics is the main core for our physics. Okay, already we are discussed in our fundamental classes. The mechanics is influenced all the physics remaining branches. Without the mechanics, we can't expect our physics totally. The light mechanics are there, the sound mechanics are there. Okay, now in the electricity mechanics is there, in the magnetism mechanics is there. Wherever you go in our physics, various branches, the mechanics is compulsory. That's why there is the numerical problems of mechanics are compulsory. Every numerical problem may contain the property of mechanics. Yes, in another electricity and as well as electromagnetism also. There is also electrical force is there. Suppose electricity is there, electrical force is there. Magnetism is there, magnetic force is there. Okay, clear or not all of you? Yes, the sound, it is a mechanical wave only. Okay, now that's why compulsory everywhere the mechanics is there. That's why we concentrate on mechanics, and there is only small part is given. Okay, clear? Small part is given. Yes, when you get the resound, you make the low sound. Okay, clear or not? It is not possible to change these all the things. Okay, now, yes, you make it is low sound, you not get the resound. Okay. Yeah, there is what we have discussed in our laws of motion, and the second lesson is also important all the students. Clear or not all the students? Motion and this lesson are very important, and it is a fundamental for our total physics. Okay, in that one we already discussed the equations of motion. Okay, clear or not all the students? And as well as in this particular lesson we are discussed about the, yes, what is the laws of motion and what is the cause of motion. Yes, especially what the cause for the motion, what the cause for the rest, why the body it is in a rest, why the body is in motion. That all the information we are discussing already this lesson. Okay, now there is the first, there is we are discussed about our Aristotle, the great philosopher Aristotle explanation. Yes, what he explained about that Aristotle. Yes, he said that there is a natural state of an earthly object is to be rest. Yes, actually whatever the objects are there in our earth, naturally they are in always rest only. If in case they are in a motion, again after some time compulsory they come to the rest only. Yes, according to Aristotle what he said, yes, every object it is in a rest only. In case they are in a motion also they are come to the rest. Then why we have to go to discussion about the motion? There is no need of a discussion about the motion. He said, but it is somewhat not correct. Yes. Yes, that's why only our great scientist Galileo is given somewhat explanation. Yes, there is a wherever the no external force is acting on the body continues its a motion state only. Okay, clear or not all the students? That is only given by the Galileo. Galileo said for us what? The Galileo said for us, yes, the object will in a motion will remain in the same motion as an external force applied on it. That is given by the first thing is first by whom? Galileo only. Galileo said that wherever the object is in a motion, there is no external force acting on it. It continues its a motion state only. Yes. That is only called what actually Galileo observation. For this purpose, you take an inclined plane, and there is when we take inclined plane, okay, now it will be, yes, changes it is. Path is inclined plane it is. At that time there is a what? When we take like inclined plane, the body moves like this only. The body moves like this only. When you take this inclined plane, because of external force acting on it, yes, that's why only the body stops and it will be again returned into the path. Okay, Mr. Somewhat the students are not listen carefully. I am going with the what? The total lesson recapitulation. I am not going with the particular page number. Okay, now. Yes, I will go with the total lesson recapitulation points. Okay. And now there is about the scientist observation. After scientist observation, our great scientist Newton is proposed 3 laws for the motion. 3 laws for the motion. Okay, now every law is contained its own identity. Yes, every law is given clear explanation about the what? About the force application, about the motion, about the rest. Why the body is in a rest? Why the body is in a motion? When the body is in a rest? When the body is in a motion? These are all the discussions we are already completed in that. Okay, clear or not all of you? Newton said for us first law, unless until the force is acting on the body not changes its a state. In case it is in a uniform motion, it is moving in that uniform motion. Okay, clear or not all of you? Yes, and as well as in case it is in a rest, it is in a rest only. Okay, clear or not all the students? I hope you got it here. Is a continuous of a state of a rest or a uniform motion. Yes, if we are not applied a force on the body. Yes, in case we applied a force on the body changes its state from rest to the motion or motion to the rest. Yes. Then before that, why the body is in a rest? Why the body is in a motion state only? Because of its one of the property. What is that property? Inertia. What is that property? Nana? That is only called inertia. Because of inertia, the body is not ready to change its original state. Okay, when we craft the inertia, when we giving a more force than the inertial force, okay, at that time only the body changes its state from rest to the motion or motion to the rest. Got it or not? Yes, and this is only about our whatever our yes our inertia and first law of motion. Which one is called inertia then? Inertia is nothing but mass. Mass of the body only works as a inertia. Okay, about the inertia and as well as the first law, already we have discussed so many things. Okay, now once you recall all the things through the textbook and through our classes, till it will be available in our app. Okay, now from October 12th onwards also till now it is available in our class. Total classes are available. May deleted after some days. That's why once again you go through classes what we are discussed at the time of this class. Okay, clear or not all the students? Yeah. Now then next we go for very important law, that is only Newton's second law. What the Newton's second law tell for us? Second law of motion. What is it is? Yeah, it is given the information about what actually it is given information about. Yes, force quantity. What is the force quantity? Here the force is directly proportional to acceleration. Yes, and as well as there is a what? Force is directly proportional to acceleration. Acceleration is inversely proportional to the mass. Okay, clear or not all the students? Force is directly proportional to the acceleration. More force is given, the body moving with the more acceleration. And as well as less force is given, the body moves with the less acceleration. But when we take in the mass, okay, clear or not all the students? When we take the mass here, yes, the mass is different here. What is the difference is there? The mass is increases, acceleration is decreases. That of the activities we already discussed. Yes, when the mass is increases, automatically acceleration is decreases for the bodies. Okay, got it or not? Yes, by using these two things, there is a because of mass, may velocity changes now. That's why there is acceleration changes is nothing but rate of velocity may changes. Acceleration is changes nothing but the velocity also changes or not? Yeah, that's why only we first concentrate on velocity and masses. That is only gives for us momentum. There is a momentum is nothing but what? Product of mass and velocities of the bodies. Product of mass and velocities of the bodies. So there is based on this one only. Once we are taken relation between the whatever the momentum and as well as the force. When you take the momentum, yes, the force is directly proportional to the momentum. Why? Because force is directly proportional to the acceleration. Okay, clear or not all the students? And from these two things, we are taken as F is directly proportional to the what? Del P by del T. Indirectly it indicates what? It indicates the V by T. Okay, now F is directly proportional to V by T, and automatically here we take in M here, M into V by T. Here we take M here, automatically it is M into V by T. MV is the what? MV is the momentum. That's why only we are taking force is directly proportional to the change of rate of momentum. Change of rate of momentum. Understood not all the students? Change of rate of momentum. Change of rate of momentum. That is only called what actually? That is only called what? Our Newton's second law. Yes? As Newton's second law said for us about the relation between a change of momentum and as well as it is proves the first law also. Okay, clear or not all the students? It proves the first law also. Okay, now it is about our Newton's second law. Newton's second law said in two statements. One is the force is acting on the body is equal to product of mass and accelerations. Yes, and as well as the force is equal to the force is acting on the body is directly proportional to the change of rate of momentum. Otherwise, the force is equal to change of rate of momentum. That is only the two formulas may get for us. Yes, by using F is equal to ma, we have to solve the result of the Newton's first law also. We get the Newton's first law also. I am given that explanation to you. And as well as there is a what will be considered here. Based on that Newton's second law only we take an Atwood machine. Okay, now for problems also. Atwood machine problems also. Okay, clear? Yes, Atwood machine is nothing but which are contain the two masses with the one string which is contained on the which is working on the pulley. Okay, now yes, when we take it that is the different masses, there is a one mass is changes another mass momentum, one mass is changes another mass acceleration based on a tensile forces. It is a very important, once again I repeat it, these laws of motion, these all are whatever we are discussed, it is all are not fundamental things only. Fundamental things may not ask in your IIT examinations. Based on fundamental things, the problems may ask for you, applications may ask for you. That is, Atwood machine is application of our Newton's second law. That's why we concentrate on it. Compulsory concentrate on it. Atwood machine is one of the very important application of our Newton's laws. Okay, that's why we concentrate on that law. Okay, got it? This is only the information about our Newton's second law. Okay, we have taken a different masses. Already I have given so many problems for you also. Yes, and may you have to solve this or not once you check it out. And you be concentrate on that Atwood machine. Already we solved for the, what is the tension formula, what is the formula of acceleration in our Atwood machine. Okay, clear or not all the students? And you are prepared somewhat problems, somewhat numerical problems based on that particular things. Okay, then next come to your very interesting and as well as very important, that is only Newton's third law. In the Newton's third law, we are already discussed it. There is some number of examples. Newton's third law is what? Every action is a contained reaction with the same magnitude but opposite in the direction. Okay, clear or not all the students? Every action is a contained with the reaction with the same magnitude but opposite in the direction. Okay, clear or not all of you? Yes, that is only called Newton's third law. The rocket motion and as well as we are walking on the earth. Okay, these are possible. We are standing on earth. Everything, these all are possible by which thing? These all are possible by the Newton's third law only. Okay, clear or not all the students? This is only about our Newton's third law. Yes, for the Newton's third law purpose, we are taking formula as F12 is equal to minus F21. F12 is equal to minus F21. Based on this one only, we are going to take our conservation of momentum principle also. What is the conservation of momentum principle? When there is external force acting on the one system is become zero. Otherwise, F net force is acting on the system of a masses r is equal to zero. Whatever the momentums are there before the collision and after the collision are same only. The momentum is conserved. Understood not all the students? Clear or not all the students? The momentum is conservation of momentum law is nothing but One of the student is given one statement here. Action and reaction acts on a different bodies and their line of action is the same. Yes, acts on a different bodies and their line of action is the same. What is the line of action? You know very well. What is the line of action? Yes, what is the line of action? Yeah. There is a what? Suppose it is the two bodies. We are taking a very important thing. Okay, there is when you take here, this is the two bodies. One is a M1, another one is a M2. Okay, now this is called actually they are meet together. They are given one is action and another one this one. May here there is a what after action and reaction may continues on this line of action or not. It is a very important. Every time may not possible it is. Okay now. Yes, the mass is the greater. M1 is greater than M2. Okay now. Far greater than M2. May not it is moving along a line of action. Yes. Clear or not all the students? May line of action changes. You know very well. There is a one marble you take here. Yes. Depending on the momentums and depending on the masses, there is a what? Line of actions or changes. Depending on the momentum and depending on the masses, there is a line of actions or may changes. Got it or not? Yes, line of actions or changes when there is a more momentums are there for one body, less momentum is there for another body. Yes. At that time there is a what changes. Here sir, what about where, just a minute sir, about that whatever the forces are present in there, first and second, third laws of motion. I am not understood your question. Laws of motion is given about the forces. Yes. What about the forces? What the forces means what? I don't know. What is the question may came from one student, that is Abdul Samir. What is your question? Once again check it here. Wherever the force is present, there are first and second and third laws of motion. Once check it now, the question. It is not in a correct form. Wherever the forces are applied. What is the limitations of third law? There is a limitations of third law means what? There is maybe friction forces. Every action may not is equal to reaction. When it is may be a compulsory, every action is equal to minus reaction. Okay, clear or not all the students? Yes, why? Because that is maybe friction, that is maybe normal force, otherwise maybe it is any other force is applied, that force is contain another reaction. There is no limit for it. Yes, there is no limit for it. Okay, clear or not all the students? There is no limit for it. Limitations of Newton's third law means there is no limit for that particular law. Every action is a contain the reaction. Every action is a compulsory contain the reaction. Okay, clear or not all the students? And there is in case when the two bodies, one is a stick together, maybe stick together at that time also. There is every action is a contain reaction. The sticking is also one type of action and may not it will be repelled. Yes, but that sticking purpose, whatever the actions are going on, that is also, yes, reaction. You know very well, when you take a gun and in that gun otherwise arrow, at that time somewhat when we are taken yes, a bow, in that arrow whatever there, that will be stick on the wall, you know very well. Yes, why? Because of that whatever rubber coated things are there, that is suddenly given the action on that wall, because of wall is a given reaction, because of that there is a what? It is a thick with that. That is only. Every action is a contain the reaction. Okay now? Yes, that is only we are taken. And now Mr. Lakshman Prasad, what you are not clear, I am not getting it. And now there is a next one is about our conservation of momentum law. What is the conservation of momentum law? What is the conservation of momentum law? Yeah, when there is no external force is acting on the body not changes. Yes, it's a momentum. Okay, the momentum remains conserved. That is only conservation of momentum law. For this purpose, you take two bodies. One body is a contain velocities as m1 u1. Another body is a contain the velocity of m2 u2. Yes, there is another body you taken as after the collision. There is both what actually? Yes, another body you take here. After the collisions, there is the bodies are changes their velocities. And because of that, momentums are also changes between velocity exchanges between the bodies. Otherwise, sometimes masses are exchanging between the one body to the another body. Automatically, the momentums are changes, and overall momentum for the net force is equal to conserved. Okay, there is no force is acting, no external force is acting on the system. The momentum remains conserved. That is only called the conservation of momentum law. From this conservation of momentum law, there is what will we get? One more important concept, that is only impulse. Yesterday we have discussed it. Okay, clear or not, all of you? Yeah, conservation of momentum law, and there is a conservation of momentum. Conservation of momentum, conservation of momentum law is gives the information about the what actually it is gives the information about the impulse. Impulse is nothing but we take here the net forces application with the time. Net forces application with the time. But in the conservation of momentum, we not take account of the time. That is only the difference. When you take conservation of momentum with impulse means what? We have taken the time is also account. But in a conservation of momentum, we are not taken time is account. Okay, clear or not, all of you? That is only the impulse is nothing but already yesterday we have discussed. That is del P is equal to taken as F net into del T. Okay, clear or not, all of you? Suppose you not taken here F net is equal to 0. If in case F net is equal to 0, the del P is equal to 0. It is only called a conservation of momentum. Otherwise, there is a time never it will become 0, not the time change compulsory. In case you not consider the time change, del T is not change here. It is also del P is equal to 0. Okay, now in case you take an impulse, you return like this. Okay, clear or not, all the students? The impulse is nothing but when you take here, there is a time with the force, that is only called impulse. Okay, with the forces are taken in the presence of time. Otherwise, our forces are taken in the basis of the time. Okay, now that is only gives the impulse. Impulse is one type of a momentum only. But we consider the momentum with the change of time, and all the forces are involved in the change of time. Okay, so many examples we have taken yesterday and given homework for you also. Yes, whatever the daily life observations are there in your day, what it is represents some impulse, that all we are discussing. Okay, clear or not, all the students? This is only about our total laws of motion lesson. Now, all the students, now you ask the doubts. What is the doubts are there? Meanwhile, in the lesson, don't ask any doubt, Nana. It is not possible to clear. Okay, yes, why? Because I am going with my fluents. Okay, on the topic, and at the time, meanwhile, you are asked the doubt, may not get your correct clarification. Now you ask the doubts. Abdul Samad, what is your doubt? Whenever there is a force is applied on the body, first, second, third laws of motion are present in the every type of force or not. The question is not correct. Whenever there is a what first and second laws of motion, first and second laws of motion, first and second and third laws of motions are given about the forces. What are your question? Whenever there is a force is applied on the body, first, second and third law, first, second and third law of motion are present in the every type of force. Okay, what is I myself I imagine that every type of force means what? There is a two types of forces are there. One is a contact force, another one is a non-contact forces. You are asked maybe about that. There is a whatever the type of force you are taking here. There is a compulsory. Our forces are applicable. Our laws of forces are applicable only there. Okay, either maybe you take a gravitational force, or maybe it is taken as our whatever electrical forces. Two types of forces are there now, contact and non-contact forces. May in this view there is your question is there. It is a very important and very big doubt, and as well as very good doubt also. Okay, there is a different types of forces are there now. Yeah, Samed, it is your question is a very good. Yes. There is a different types of forces are there now. Yes. What is the types of forces? Contact forces and non-contact forces. In your 8th class you are studying. Yes. Our first and second and third law of motions are applicable for contact and non-contact. Both forces are not. This is only your question. Okay, correct? Yeah. In case it is only your question, it is the correct only. Okay. Yes, every force is under our laws of motion only. F is equal to ma format only, but we'll get somewhere some changes. Suppose you take a gravitational force. How we written the gravitational force? F is equal to written as G into m1 into by r square. It is only the gravitational force actually. Yes, here it is not looks like it's F is equal to ma. Okay, but it is about contain the acceleration terms inside it also. Okay, clear? And also suppose you take electrical forces. Yes, electrical forces. F is equal to 1 by 4 pi epsilon naught into q1 q2 by r square. This is electrical forces. It is also in the form of what actually? It is also in the form of our forces laws only. Okay now? Why? Because gravitational force said for us, yes, gravitational forces are said for us. There is a when you take a two masses, the force is acting on the bodies is directly proportional to product of masses, and it is inversely proportional to the square of the distance between them. Okay, clear or not, all the students? Square of the distance between them. These are only concepts we are taken. Okay, now, but maybe it is a gravitational force, maybe it is a non-contact forces, maybe it is a contact forces. Okay, now, maybe it is a contact or maybe it is a non-contact forces. Our laws of motions are applicable only. Okay, now, yes, whatever the type of forces you take it is applicable only, but not in our laws of motion format, in another way. Depending on the particular nature of force, it may applicable. Suppose you take a tension force. For the tension force, what formula we have to written? T is equal to mg. We are not taken A here. We taken E here. What we are taken? Here G we are taken. Gravitational force we are taken. Clear or not, all the students? Yes, this is only about our changes they are considered. Mr. Spurtik, just you are check your friends only. You listen the class. How the good doubts are your friends may ask. Yes, very important doubt it is. Yes, thank you, Mr. Samit. And next, one more doubt is also came from another student. Yeah, the product of force and time that produces a finite change in a momentum of the body is called impulse. Very good. Yes, the product of force and time that produces a finite change in a momentum of the body, that is called actually impulse. Okay, it is also one of the definition only, and as well as there is a what we are consider the net forces are taken into in the presence of a time. Okay, now yes, when you taken there is a forces. Okay, directly we are not consider the time. F is equal to ma means what? There is we not consider directly the time. Okay, now yes, but when we take account the time for the forces, may will get the momentum changes are also may get for us. Okay, clear or not all the students? Impulse is nothing but we are when we are taken there is our change of momentum. Okay, now yes, the change of momentum is a possible. Yes, there is a net forces, whatever the net forces is taken with the time. The taken with the time. Okay, clear? So many examples when you take the ball. Okay, when you take a chalk piece. Okay, now chalk piece is not broken. When it is a fall on the floor, it broken. Because of what? Yes, we taken the what momentum change for a time. Okay, now just we are changes the time to apply the forces on the bodies. Okay, now we take a more time. Okay, now we get the what less momentum change. Okay, momentum may become reduces. Okay, now suddenly we are taken, the more momentum it is there, it is gives the damage to our body. Okay, now damages to the bodies. Okay, now that is only we can take in here. Yes, already we have discussed all the things, and Atwood machine. Some students may ask the question about the Atwood machine. Yes, Atwood machine is nothing but already we have discussed. There is we taken a pulley, and as well as there is a what we have taken, the thread we have taken, otherwise the string we have taken like this, and here we are attached the mass, and here we attach the mass. Okay, now yes, and here we taken it is a M2 mass, otherwise we taken M1 mass, and due to the tension forces, okay, now it will be work opposite to the gravitational force. Okay, because of that may there is a whatever this M1 and M2s are there, they changes their positions. Okay, clear or not all the students? M1 is always try to come here in this particular situation when we take an M1 is greater than M2. Okay, now M1 is always wanted to move in a downward direction because of a gravitational force acting on it. Okay, this is only called Atwood machine. Okay, now once go through the class. Okay, why? Because now for the total explanation is not possible. Once go through the class and given the explanation for it. Okay, now in case you taken there is the same Atwood machine for M2 greater than M1, M2 greater than M1, it will be taken as like this. Okay, clear or not all the students? Yes, now the body is M2 is here, it will be moves like this, and M1 is here only. M1 is here only. Okay, got it or not? Yes, now it will be moves in this direction, it will be moves in this direction. Got it? This is only about Atwood machine. Any more doubts? Yeah, now we go with that examples. Yeah, we go with our so why the M2 goes up with the force acting on which force? There is a what here when you take care here M2 is a travel in a direction, in this direction. Why? Because indirectly there is on this particular point tension is acting on it. The tension is a came from where? The tension is a came from as gravitational force of the M1 body. The gravitational force on M1 body. There is a two forces are working. Initial forces is applied on it, and as well as it is also influenced by the gravitational force. Okay? Yes. This is only about the concept of different topics whatever we discussed. Example questions, whatever the example question it is here on impulse it is a given. A cannon of mass of the data is given from that example 4. Example 4 we are taken. The data is given. Yes, what the data is given here? The data given as M1 is equal to taken as M1 is equal to taken as 1200 kgs, and as well as what they are given, M2 is equal to given as 300 kgs. And one more thing is given, that is horizontally the direction of velocity is a v2. Yes, it is taken as what actually? v2 is taken as 400 meter per second. 400 meter per second. We have to find out the v1. Clear or not, all the students? Then what is the formulas we are taken here? Here we are taken as the formulas of our conservation of momentum law formula we have to take here. What is the conservation of momentum law here? M1 u1 plus M2 u2 is equal to M1 v1 plus M2 v2. This is only the formula we have to take for it. Our conservation of momentum purpose. You know very well about this one. And here there is the initial velocities of our bodies are become as 0 here. Okay, they are given already. There is a what they are given. Yes, internal forces, the external forces are 0 here. Okay, now yes, there is a both are same. That's why there is a sum of these two things are 0. And by using this formula only we have to find out here. Why? Because here the initial velocity u1 is equal to 0 and u2 is equal to also 0. And now there is it is become what? M1 v1 plus M2 v2 is equal to 0. Now it is also written as M1 v1 is equal to minus M2 v2. Here v1 is equal to taken as minus M2 v2 by v1. You substitute our these all the values whatever there, M2 is there, M1 is there, and as well as whatever, sorry, M2 is there, V2 is there, and M1 is there. You substitute that our values in this equation, you will get it. What that 300 into 400 into 1200 kgs, automatically it is become V1 is equal to minus will be get for us. Minus is indicate opposite to the direction of V2. Okay, M1 body is a contain velocity. Yes, V1 is opposite to the V1. Velocity direction is opposite to the M2. Okay, clear or not all students? This is only about actually laws of motion. Got it? Got it or not? Yeah, I hope you understood. Once again you read the total lesson. Okay, tomorrow we'll go with the remaining problems and question answers. Okay, thank you students. Bye, take care.